Have you ever wondered why astronauts grow taller in space? It's not a trick question, nor a science fiction plot. It's a fact, a fascinating phenomenon that has puzzled and intrigued scientists for decades. Picture this: an astronaut, having spent months in the infinite expanse of space, returns to Earth and suddenly finds himself or herself towering over friends and family. It's not an illusion, it's not a magic trick, it's space science. And it's as real as the stars that twinkle in the night sky. Now you might be thinking, how is that even possible? Well, it's not just possible, it's a common occurrence for those who venture into the cosmos. The first time scientists noticed this, it was nothing short of a surprise. But as more and more astronauts ventured into space and returned slightly taller, it became clear this wasn't just a random occurrence, but a consistent pattern. And so, it piqued the curiosity of the scientific community. Was it something in the space food? Was it the result of high-intensity workouts aboard the International Space Station? Or was it something else entirely? As it turns out, it's a little more complex than that. This growth isn't permanent, though. Within a short period after returning to Earth, astronauts revert back to their original height. So, it's not as if they're gaining a lifelong advantage in the height department, but the fact remains, they do grow taller in space. Now, this isn't just a quirky space fact, it's a significant observation that has implications for long-term space travel and our understanding of the human body in different environments. It's a topic that continues to be studied and researched, as we, the inhabitants of this blue planet, continue our cosmic journey. Intriguing, isn't it? But how does this happen? Let's dive into the science behind it. First, we need to understand the role of gravity. Gravity, that invisible force that keeps our feet firmly planted on the ground and the planets in their orbits. It's an essential part of our everyday lives, from the way we move to the structure of our bodies. Let's delve into how gravity impacts us, especially how it compresses our spines, making us slightly shorter than we really are. So, what is gravity? It's a force of attraction that exists between any two masses, any two bodies, any two particles. It's intimately involved in how our universe is structured and how it behaves. For us here on Earth, gravity pulls us down, anchoring us to the ground. Now, how does this relate to our bodies? Well, our bodies are structured to withstand Earth's gravity. Our muscles and bones developed in this environment, and they're used to constantly working against this downward force. An interesting part of our body affected by gravity is our spine. Our spine, or vertebral column, is a stack of 33 individual bones called vertebrae. Between each vertebra there's a disc, a kind of shock absorber that provides cushioning and flexibility. Now, throughout the day, as we're up and about, gravity pulls down on our spines, and these discs get compressed. This compression is why we're actually a little bit shorter at the end of the day compared to when we wake up in the morning. So gravity, which seems so ordinary and unnoticeable in our daily lives, is constantly shaping us, literally. It's molding our bodies, compressing our spines, and even influencing how we perceive our world. Now, imagine what could happen if this compressing force, gravity, was removed. What would happen to our bodies in a place where there's no up or down, no sense of weight? Would we be taller, shorter, or something entirely different? Stick around as we journey into a world without gravity in our next segment. Welcome to space, a zero-gravity environment. You might be wondering, what does zero gravity mean? Well, it's pretty much what it sounds like. It's an environment where the force of gravity is so weak that it's almost non-existent. In other words, things don't fall down in space, they just float. Now, what does this have to do with astronauts growing taller? Let's take a step back and think about what gravity does to our bodies here on Earth. The force of gravity is constantly pulling us down, compressing our spines, and keeping us grounded. In fact, you might not realize it, but you're actually a tiny bit taller when you wake up in the morning than you are at the end of the day, because your spine decompresses while you sleep. In space, where there's no gravity pulling you down, your spine doesn't have that constant pressure. It has a chance to fully decompress, and as a result, astronauts can grow up to 2 inches taller during long missions in space. It's like a supercharged version of what happens to your body while you sleep. But here's the thing, this isn't like growing taller during puberty, this is a physical change caused by the environment. The bones aren't growing longer, it's the spaces between the bones, the spinal discs, that are expanding. And just as a side note, this isn't always a comfortable experience for the astronauts. Imagine your body stretching out but not evenly. Some parts grow more than others, and it can cause back pain and other discomforts. So, in a nutshell, that's why astronauts grow taller in space. The zero-gravity environment allows the spine to decompress and expand, resulting in a temporary increase in height. But wait, is this growth permanent? What happens when astronauts return to Earth? Coming back to Earth after a space mission isn't just a geographical transition. It's a physical one too, a realignment of the body back to its terrestrial state. You see, the elongation of an astronaut's body in space is not a permanent change. It's a temporary adaptation to a zero-gravity environment. So what happens when gravity comes back into play? Upon re-entry into the Earth's gravitational field, an astronaut's body begins to compress once again. This happens because the spine, which had expanded in the absence of gravity, starts to feel its pull again. Imagine a spring that's been stretched out but then released. It naturally returns to its original state. That's essentially what's happening to the astronaut's spines. But it's not an immediate change. Just as the body took time to adapt to the weightless environment of space, it also takes time to readjust to the gravitational pull of Earth. This transition period can be a bit uncomfortable as the body has to relearn how to function under the weight of gravity. The astronauts might experience back pain, muscle weakness, and a noticeable decrease in their height over time. But don't worry, it's not all discomfort and shrinking heights. There's a silver lining to this gravitational readjustment. The body's return to its pre-spaceflight state is a testament to its incredible resilience and adaptability. It's capable of withstanding drastic changes in environment and can bounce back to its original form, albeit gradually. Moreover, this temporary height increase gives scientists and researchers invaluable insights into how the human body adapts to different environments. It helps them understand the physiological changes that occur in space, which is crucial for the future of space exploration. So the height gain is temporary, but it's an interesting part of being in space, isn't it? It's a reminder of the fascinating ways our bodies adapt to new environments, the resilience we possess, and the mysteries that space continues to unfold. Now, isn't that something worth standing tall for? So, why do astronauts grow taller in space? As we've explored throughout this journey, the answer lies in the fascinating interplay between our human physiology and the forces of gravity. Our journey began right here on Earth, where gravity plays a crucial role in shaping our bodies. The force of gravity compresses our spine, subtly shrinking our height as the day progresses. We're actually a bit taller when we first wake up and gradually become shorter as our day unfolds. This is a daily, unseen dance we all partake in, governed by the fundamental forces of nature. Then we ventured into the cosmos, to a zero-gravity environment. The absence of gravity in space gives our bodies a break from the constant pressure. Our spine decompresses, and as a result, astronauts grow taller. It's a fascinating adaptation, a testament to the flexibility and resilience of the human body. This growth isn't permanent, however. Upon returning to Earth, the familiar force of gravity resumes its role and the astronaut's height returns to normal. This phenomenon is more than just an interesting factoid. It's a reminder of how our bodies are designed to adapt and respond to different environments. It's a testament to our innate ability to survive, evolve, and thrive, even in conditions that are vastly different from those we evolved in. But these changes aren't without their challenges. The decompression and subsequent recompression of the spine can cause discomfort and require physical therapy upon return to Earth. It's a small price to pay for the opportunity to explore the cosmos, but it's an important consideration for future space travel. In essence, the mystery of why astronauts grow taller in space unravels a complex tapestry of human physiology, celestial mechanics, and the adaptability of life. It's a fascinating glimpse into the intricate dance between our bodies and the universe that surrounds us. Next time you look up at the stars, remember, the astronauts up there are just a little bit taller than when they left Earth.